this is number 7, identification and authentication failures. It used to be pretty high up. I think number 2. Let's see. That's right. Yeah. So let's think it's actually in the previous one. So yeah. So you can see it used to be called A2, broken authentication. And then they renamed it to identification and authentication failures. And it's 7th on the list instead of 2 because on the surveys they did, which they used to build the OWASP top 10, they found that there's a bunch of frameworks now available to help with authentication, primarily around multi-factor authentication, that are now widely used rather than back in 2017 when they were more rare. And so now it is less severe than some of the other issues in the OWASP top 10. Still very important though. This is basically your password getting compromised, or people using your web application to compromise a user's password through a set of weak authentication protocols. So let's take a look at these. So okay, so permits automated attacks such as credential stuffing. So credential stuffing is fairly common. That's when you take some known passwords that have been breached in the past through various sources. So like, and then you use that list of passwords to try and guess users' passwords. You go through like the most commonly used passwords, and then you try and use them over and over again. And so CRA, CBC News, credential stuffing. So recently in the news, there was a so cyber attacks targeting CRA and COVID-19 payments. This was a credential stuffing attack. You can see here. Yeah, so using people's previously used credentials from maybe other websites or commonly used credentials, and then logging into their CRA accounts to claim COVID benefits on their behalf, and then get the money. So that's a recent cyber attack. So 11,000 of them had this issue. Okay, so this is fairly common. So what can we do about it? There's the things like using MFA. That's the big one. So if you don't know what MFA is, you use a second factor for authentication. It's the sort of something is your password. So you know your password, you log into the website in question, but also something you have. So like a device or your phone, right? It's another factor to allow you to authenticate. So you use the code, use a code. So if you log into a website, you use a code to log into. We'll actually do an MFA demonstration later on. So you can implement password checks. So you can, if a user tries to log in with a create an account with a weak password, you can check that against a list of known broken passwords and say, don't use that one, use something else. Have I Been Pawned has an API actually to do this for a list that's much larger than the worst 10,000. Can also add password complexity requirements, although don't get too crazy with it. NIST 863B provides some information. Password. We talked a little bit about this inside secure design. Previous session we had. Again, those are available Hackforge on the Hackforge website. You can see them here. So yeah, secure designs, this one over here, right? So you can go and look at that. We talk a lot about actually NIST 863B and how to design secure password requirements without going overboard, which is actually an anti-pattern. Good. All right. So that is identification and authentication. Before I go and demonstrate some things, do you guys have any questions? Okay. So now for the fun part. So I have an application running here. It's called Chatsploit. Those that have been here before are familiar with Chatsploit. It's a chat application. So I'll go to localhost here and load it up. Hopefully. It's compiling in the background. Okay, good. So it's an application I built that has very poor security implementations to help demonstrate security issues. You can go see this on my GitHub. Yeah. GitHub.com/John Haldeman. You can actually download Chatsploit if you like. Don't use it because it's full of security holes. That's sort of the point. So don't use it as an example of good coding. What you can do though is download it, run it, and then perform a whole bunch of exploits against it. All the examples we do in those videos and in previous weeks and this week. So Chatsploit 2, actually, Chatsploit 1 was a previous version. So yeah, go to Chatsploit 2. You can go and get the code and do all of this work. So I have Chatsploit here, and it's a chat application. So you go, you can find friends, and then chat with them. So if you want to use Chatsploit, you have to log in. Very slow today. Bear with me. Okay, so if you use Chatsploit, you have to log in. It'll soon forward us to the login page. If it why is it so slow? Come on. Just everything's aching. Yeah, come in. Thanks for joining. All right, so we're doing OWASP top 10 number 7. Identification and authentication issues. Having a little trouble with my application here, but maybe I broke it. Maybe I broke the forwarding. Bear with me. So slow. Okay. I must have a. Yeah, let's try this with. Must be logged in already. There goes me. That's the problem. So I'm going to use an incognito window now to clear my cookies. Compiling. You can see it compiling in the background. Okay, good. All right. So Finally, we get a login window. That was supposed to happen. It didn't happen in the previous window because I was actually logged in. I just forgot I had done that. Also can't close Chrome completely because then we'll lose our Chromecast. Anyway, so you get it's just a regular application. Everyone's familiar with the login window, right? You click login. My failed login message is very bad here. Again, don't use this application as a good example. Use it as a thing that you can hammer against in order to exploit stuff. So okay, so we have this here, and you're an attacker, and now you want to try and get John H's password. If you go and look at the development tools inside Chrome, and you go to network, and yeah, we try the login message here. You can see it does a post against API login, and you get an invalid username and password combination message. So that's how it checks the login form. If you log in successfully, let's do that. Then you get a done true, and part of the response is like a cookie set to set the response here. It sets the cookie to the JavaScript web token. That's what the authentication uses. So that's all working. So the question is, so an attacker knows what a failed login looks like and what a good login looks like, which means now they can script trying different passwords. So here's my my script. You guys can see this okay? Maybe we need to make it bigger. That's better. All right. So what I downloaded from the NCSC, which is kind of like the NSA, but for the United Kingdom, is they host a list of the top 100,000 most used passwords. So what you're supposed to do is use this list, right? So these are the most common passwords. What you're supposed to do is use this list inside your application. And you say, okay, if anyone uses any one of these passwords when they're signing up, you say, hey, don't use that password. It's been compromised many, many times. But an attacker like me can now use this list to try and log in to that application in order to guess people's passwords. This is effectively credential stuff. So I have my list of passwords, and then I have a script, which is a shell script. That all it does is you give it a username, and then it uses curl. So you don't have to be very sophisticated. It uses curl against API login, and then if we get the failed login message, we print whatever the password was to the screen and go to the next one. But if we get the successful login message, then we print the username and password to the screen. So let's do that with John H. So, all right, so I tried 4. Turns out my password's password. It's a very bad password. Don't use the password. It's number 4 in the list. There's let's say if you were a little bit more creative and you choose another password, like this guy named fdude, right? So it's going to try more passwords against that API endpoint, that login endpoint. These old passwords. Do any of these look familiar to you? Do you guys use any of these? Anyway, so fdude, way down the list, QAZW QAZWSXEDC. So if you that's like if you look at your keyboard, if you keep going down QAZWSXEDC, that's what people use. Just going down vertically on the password on the keyboard 3 times. Okay, so that's credential stuffing. So that's how they compromise so many accounts. So how do you prevent credential stuffing from being an issue? So there's one way to try and help mitigate it, to make it harder on the attacker, is rate limiting. So we'll do rate limiting first. Then the best way, though, is multi-factor authentication, MFA. And so I'll explain MFA after. So this is let's do rate limiting first. So when you have a server, we have in the last session we talked about, or maybe it was 2 sessions ago, we talked about how we have our web application listening on port 3000, and then we have a HTTP server listening on port 80 or 443, Nginx. So Nginx proxies the data to our application server. The reason you might do that is because Nginx provides you a whole bunch of features. One of the feature that we used last time was these image loading. So we hosted the images on Nginx, so separate from the application. So the application doesn't need to know about your static assets. So that's great. But another reason you might want to use Nginx, because it has things like rate limiting, so you don't have to implement that inside your web application. And so that's what I have to do this as a root. Okay, so do it with so it has rate limiting. What this is going to do is anything proxy to localhost 3000, which is my application server, we're going to allow a burst of 20. So you allow 20 HTTP calls sort of immediately, but then 1 request per second afterwards. So it's kind of good to have a burst, because web applications tend to be bursty. You load a web page, a bunch of stuff happens very quickly, a bunch of resources get retrieved, and then it's quiet. So you want to allow bursting, but at the same time you also want to prevent a large number of requests per second from occurring. So 1 request per second. That's effectively what this does. You can go and look at the Nginx documentation on what all this stuff means, but this is basically a shared memory location that keeps track of per IP. So this is 1 request per second per IP, per client IP. And so yeah, okay. So now I've uncommented that in Nginx, and we'll restart Nginx. Okay, so Nginx is restarted. And so now we'll try the same attack as we had last time. So John's password's so easy, doesn't really do anything because we're in the burst, right? So it still doesn't help John out. Does it help F-dude out? Let's see. So pretty fast at the beginning, and then it slows down, right? So this doesn't prevent the attack from occurring, but it mitigates it. It's one of the things you can do. One of the things you can do in the put in between to prevent to help make it more difficult for these attacks to occur. Another thing you can do is maybe after a certain amount of executions, you ban the IP. Common thing is like fail to ban. That's another thing you can do. OWASP recommends, but you want to watch out for that because you don't want to create a denial of service situation, right? So if you ban, if a whole bunch of people are using a shared IP, maybe it's a library, and it's a very popular website. Everyone loves using chats for it at the library. Then some mischief maker can go and get that IP banned, and then nobody has access to the website. So you got to be a little bit worried, a little bit careful about banning. Okay, good. All right, so that's one thing you can do, rate limiting. But before we go on to MFA, is there any questions? Anyone who's on the Zoom can put the questions into the chat. We can answer them too. Any questions here? Good. All right. Makes sense. Okay. All right. So now we'll look at MFA. So MFA, like I said, it's, you need two things: something you know, which is our password, and something we have, which is like your phone. So common MFA mechanisms are like SMS messages, right? So if you log into Google and then you choose to use SMS, it'll send you an SMS message. SMS is susceptible to things like social engineering. Lots of people don't like SMS logins and discourage, well, as an MFA factor, and discourage it. It's still better than nothing, though. So if you're gonna, if the choice is SMS or nothing, go with SMS as the second factor. Now, another way to do it is with email, right? So if you log in, a website will send you an email, and then with like a 6-digit code, and then you use that 6-digit code to log into the website. All of that stuff tends to cost money to send. So I'm going to show you an MFA mechanism called TOTP. Has anyone used TOTP before? So time-based one-time password. That's what TOTP stands for. Used to be common. Used to get like these little tokens, like RSA things you put on your keychain. Anyone? Yeah. Well, YubiKeys is one, and you can do TOTP with YubiKeys. But like it used to go on your keychain and didn't plug into your computer. It was just like it just flashed a number. Do you guys remember those? Yeah. So that was a TOTP thing. Those sort of fell out of fashion and instead people use apps on their phone. Google Authenticator is a common TOTP one. I'm going to use IBM Securities because I work for IBM. IBM Verifies, and I already have it on my phone. So I'll show you what that looks like. All right. So we're going to log in with John H here. And John H is already registered with multi-factor authentication, but I'm just gonna register them again with TOTP sign up. So how TOTP works is you generate a secret within your application. It's a 32 character secret, normally done with a random, using a random string. So the application's generated a secret here, and then represented the secret as a QR code. But if you go and look at the image of this QR code, if my laptop wasn't struggling so much, come on. Okay, so if you look at the image for this QR code, it's actually just using a Google API, and there's this is the payload. So what I did was I generated this image. If you go and get the text from the QR code, it looks like this. So this is the keeps changing. That's because the development tools are on, and so every time like the dev tools are trying to refresh the page, every time it refreshes the page, it generates a new QR code. So yeah. Anyway, so that's what the QR code looks like. It says OTP auth TOTP John H secret this. So this is the 32 byte secret we generated, and then that's the QR code representation of that. So now I take my phone and go into the Verify app and click a button. Everyone is here, right? So I'm using my phone, and then I take a picture of the QR code, and it registers it in the phone and says I'm done. And now if I go to that app, you see the code there. So this is the one-time code, and you see it refreshes every 30 seconds. So this is the one-time code, the one-time password, TOTP, right? This is the one-time password that you can use to get into the applications. Now it's signed up, right? So which is great. And if I log in again, then I just use the code that's on my phone. This is actually just the same algorithm under the cover share. So you can go and get any kind of TOTP library. I used OTP-lib from NPM. Okay. So OTP-lib, and then I have the secret. So if you know the secret, you don't have to use your phone at all. You can just use OTP-lib with the secret to generate the code. Should be the same. Yep. So the number over there, 43975, matches the number on my phone. So all it's doing is to confirm that that I have the secret in my phone. All it's doing is generating the same number using the same algorithm, time-based algorithm, and then comparing the numbers. So that's all it is. Then inside the application, everyone gets a different secret. Every user gets a different secret, and you store these secrets inside their with their user profile. Good. So that is multi-factor authentication. Good. All right. So to review, we looked at credential stuffing. This isn't really we looked at credential stuffing. We put in MFA to help mitigate to help prevent credential stuffing from occurring whatsoever. But also, it's kind of important that even if you have a second factor which prevents this problem from happening, ideally you don't want passwords to be too easy to guess, and so things like rate limiting help. And then and also you just prevent your users from signing up with bad passwords to begin with. It's to help with identification and authentication problems. Good. Is there any questions now? Okay. All right. So that's top 10, number 7. Any questions on the Zoom? Okay. Do you want to have some fun? All right. So recently, this guy built the password game. Has anyone played the password game? All right. So it's a funny web thing about having ridiculous password rules for your users, right? So okay, let's pick a password. Someone pick a password. Oh yeah, that's right. All right. So okay, correct. Horse battery staple, right?
Yeah.
Battery staple. For anyone who doesn't know what that is, it's an XKCD comic. So it's yeah, there's this about password rules, right? So you people make you do a whole bunch of crazy things with password rules, but really, and you might think think of a really hard one to do, but then it's hard to remember. And then correct horse battery staple is actually much harder for a computer to guess, and you'll never forget it. That's anyway, XKCD, good time. Anyway, so correct horse battery staple. So okay, your password must include a number. So let's add a number. Password must include an uppercase letter. All right, so we'll add an uppercase letter. Must include a special character. What special character should we do? A hashtag? Sure. All right. Hashtag. I always do exclamation mark. I don't know if I'm excited that hashtag works. The digits in the password must add up to 25. Okay. All right. So 2 and 1 is 3, right? So we can do like 9. Which is what, 12, and then 9, which is 21, and then 4. All right, all right. Password must include a month of the year. All right, so so we can do like January. Okay, let's include one of the sponsors. All right, Shell. Roman numerals and password should multiply. The Roman numerals should multiply by to 35. Okay, so the Roman numerals, yes, we have a Roman numeral in here. What do you think the Roman numerals are? That was password rule 7, which we did by mistake. Like it says L. Let's take out all the L's. There's the, oh, it's the C, right? Correct.
That's quite a rule.
Yeah. Okay. All right. Now I must include a Roman numeral. Okay. So let's go IV. This V. Okay. Includes a Roman numeral. Should multiply to 35. Okay. So now we need 7, right? So V and VII. All right. And okay. Shell. Okay. And then, oh, it has to include the capture. So R. Anyway, GECM. Oh, the digits now must add up to 25. Wow, we're still okay. Oh, okay. R8 GECM, and now I have to remove 8 from here. Okay, password must include today's Wordle answers. Then I go to Wordle. Anyway, go play the password game. It's fun. See how far you can get. You get to like number 18, and then it shows you a chessboard and says that your password must include the next best move, and stuff like that. Anyway, so Neil.fun. He has a bunch of good stuff. All right, that's all I got. All right, thanks everyone for joining.